Okay, so before we move on, I want to make some pointers or conclusions on negative feedback. So let me take this model again. So this is your negative feedback. Now please remember that the input output quantities in general can be any physical quantities. I can say xi and xo. Now in circuits, the quantities that we are interested in are voltage and current. So which means xi can either be voltage or current. Similarly, the output can be either voltage or current. So which means how many possible combinations I can have now? I can have 4 possible combinations to have negative feedback system in circuits. And the most common thing that we always encounter is where both the input output quantities are voltages. So this is Vi and this is Vout. So if I show you some system like this, what kind of a control source do you think this is trying to mimic? Voltage control? Why? Yeah, at the output, the negative feedback is trying to make the output voltage to be a constant. So at the output, it is a voltage or a current source. At the output, it is should be clear, it is a voltage source, and this output voltage is kind of controlled based on another voltage at the input. So this is mimicking a voltage controlled voltage source. So this is referred to as voltage feedback. Where the first voltage here refers to the output quantity, second here refers to the quantity that you are sensing and comparing. And in fact, if you look at this block, if you look at the block I am highlighting in yellow, this itself is a voltage controlled current source, right? It is voltage controlled voltage source, right? The output is voltage and the output is based on difference between two voltages. So you already have a voltage controlled voltage source with a gain A. So again, the question is, why do I put it in feedback and make another voltage controlled voltage source? Why do I do that? What is stability? I don't know anything. Yeah, that's the whole point, right? Again, if I have a voltage controlled voltage source with a gain A, if the gain A changes, everything changes. But if I put it in feedback, what can you say about the gain? If A is really large, what can you say about the gain? 1 by? That's the whole point. So the understanding is, I can have within quotes a bad voltage controlled voltage source. Now if I take a bad voltage controlled voltage source and put it in negative feedback, it becomes a better voltage controlled voltage source. Right? And let me actually redraw this as voltage controlled voltage source model. So these are the controlling ports. So if this is say Vx, this is going to be A times Vx. Right. So this is going to be your normal voltage controlled voltage source in open loop. So one of the non-idealities can be the fact that the gain A changes a lot, but we can add more non-idealities. So at the output, this is behaving like a voltage or a current source. At the output, it is a what kind of a source? So if I had to introduce a non-ideality at the output side for this voltage source, what can I introduce? Resistance where? I can add a series resistance to this voltage source. So let me call it some RO. Similarly, at the input side, I am trying to sense voltage. So if I had to introduce another non-ideality at the input side, what can I do? I can put a finite input resistance. I'll call it Ri, because ideally you want to make sure that if you have some input voltage, the input voltage can have some RS. If you connected, the entire voltage of V in should be sensed across the port, which means ideally the input resistance should be infinity. If it is non-ideal, you will have a finite input resistance. So this is your non-ideal voltage controlled voltage source. Now our claim is that if I go and put it in negative feedback, as long as A is large, this becomes a better voltage controlled voltage source. So let's check it. At least we verified that the gain is constant, right? Gain is roughly constant. That much is done. So let me actually put it in negative feedback. So this is the output. I'll take the output. Let us say I have the feedback factor beta, and then I feed it here. Correct? And this is where you go and apply your input voltage. Is that right? Let me move to next page. So let's try to find what happens to the input resistance when I put it in negative feedback. So how do you find the input resistance now? I give you the circuit and ask you to find the input resistance. What do you do? Apply test voltage where? Yeah, so instead of this V, I go and apply a test voltage. So let us say I put a test voltage and I find the test current and do it. I'll just give an intuitive explanation. See, in my negative feedback system, as long as the gain A is really large, what can you say about the input and the feedback signal? Same. Again, the idea is, if it is a negative feedback, this gain A is going to be really large. So which means, what can you say about this error signal? So which means the input and the feedback quantities must be equal. So which means this is the input quantity, this is V test. So what can you say about this voltage now? That will also approximately be V test. So what can you say about the current flowing through RA now? It's approximately 0. So what can you say about the test current now? So which means input resistances. And this is true if your gain A is actually infinity. Now we can assume a finite gain and work out using KCL. That's trivial. You will find that the input resistance becomes RA into 1 plus A beta. So at least it is clear that at the input side also this has become a better voltage controlled voltage source. So I will remark it here. My Rn increases. Right? So let's also look at what happens at the output side. We'll erase this. So this is your negative feedback system. So if I were to find the output resistance, what do I do? Apply test voltage where? What will I do to the input voltage? I'll make it 0 because I don't want this fellow to contribute to the test current. So which means let us say apply a test voltage and I find the test current. So again, remember, this is, can think of it as an ideal beta, so no current flows here. So the entire test current flows here. So if this voltage is V test, what can you say about this voltage? This is V test scaled by beta. So then what can you say about Vx minus beta V test? So what can you say about this voltage now? Minus A beta V test. This voltage is how much? So what is the test current now? V test into 1 plus A beta by so what is my R out now? So which means the output resistance has become much smaller than what you had before. Even at the output side, we have made it a better voltage control voltage source. So I'll remark it here. So I find that even my output resistance decreases when I put a negative feedback. Is it okay? So this is where again a common point of confusion among students. So the common misconception is, the input resistance in negative feedback always increases, the output resistance always decreases with negative feedback. Do you think that is true or incorrect? Why? I mean, assume that A beta is really large. I mean, depending on the can you partially correct. Can you explain? No. Sorry. Yeah, I mean, the idea is, see here what kind of a feedback we are looking at. Voltage feedback. So we are trying to mimic what kind of a control source? Voltage control voltage source. So which means if I put this control source and put a negative feedback, this becomes a better control source. That is why in this case, because we are interested in making a VCVS, with feedback the output resistance decreases and the input resistance increases. For example, I can have a case where, say, the input quantity is Vin, maybe the output is not voltage, it's a current, right? So let's take that. Let me see. So now I am not interested in the output voltage, I am interested in the output current. So let's draw the feedback loop properly. So here it is output current, but I have to compare it with the voltage. So I should basically take my current and convert it to a voltage in the feedback path. Is that clear? So at the output end I have current, but I have to compare with an input voltage. So I should convert the current to voltage. Let's say you are doing it somehow. So I'll just say that you have a black box here that converts current to voltage. So here I have a voltage, I am converting it to a current. So this is no longer gain A, this is some GM. So here what kind of a control source we are trying to make now? Voltage control. Clear? So which means if I were to give a name for this feedback, what will it be? At the output, is it voltage or current? At the input, this is current voltage feedback, you can call it. So once again, as long as I have a really large GM, right, then what can I comment about this quantity, the signal here? If the GM here is really large, what can you say about this voltage here? Why? Yeah, I mean the output currents are going to be finite, so which means for large quantity this is 0. So once again you will find that the input voltage will be equal to the current scaled by some factor. Okay. And in this case, if I try to make this, of course, what can you say about gain? Will be constant as usual. So what do you think will happen to the input resistance? Should this have a large input resistance or a small input resistance? Why large input resistance? At the input I am trying to sense a voltage or a current. If I were to sense a voltage, should I be presenting a large input resistance or a small input resistance? I want the entire voltage to drop, so Rin must be, what can you say about R out here? I am at the output, what kind of a source I am doing? My output resistance should be, so which means if I make this kind of a feedback, the output resistance will actually increase. And we can look at a circuit example quickly. See, one way to realize a large GM is like this. So let me first show that. So instead of having one single block which has a large GM, I can assume that first I take the voltage, amplify it, and then I give it to a small GM. Now if I put this in an yellow box and sell it to you, at the input you have a voltage, at the output you are pumping out a current. What is the overall transconductance of this block? A into, is that clear? So this is one way to get a large GM, right? I mean, you don't have to sit and make one GM which has a really large value of GM. You can do this. So let's actually try to make this in circuit. So let's say I take a poor voltage controlled voltage source, which is this thing. What is the simplest voltage controlled voltage source you can think of? What is the simplest voltage controlled voltage source you can think of? Yeah, it's a MOS transistor. Right. So where will you apply the inputs here? Gate or somewhere else also? Only gate, or can I apply somewhere else also? I mean, across gate to source I can apply, and the current flows from. So this is going to be my output current. That also is copied here. So this is my poor voltage control voltage source. Now the understanding is that if I go and put it in negative feedback like this with a large enough gain, this will become a better voltage control current source, correct? So let's try that. So I have my I out here. Maybe I'll copy paste this, hold on. I'll keep it to this end as a reference. So I have made this fellow poor voltage control current source. That is done. Now let us say I want to take the current and convert into a voltage. What is the simplest way to convert a current to a voltage? I have a current, I want to convert it to a voltage. What is the simplest thing? The resistor. So let us say I go and put a resistor here, correct? So let us say this is Rx. So this is your feedback signal, right? Now I have taken this current, converted into a voltage. So my feedback is ready. Now all I have to do is take this voltage and another input voltage. So feedback voltage and this input voltage needs to be subtracted and gained up by a gain. So we can have, this is V in. So all I need to do is take the difference between the two and amplify it. So what does it? I need to take the difference between two voltages and amplify it. What is the simplest circuit that you know? Some diff pair, some diff amp. So let us say you put some gain here. And what should be the plus and minus here? If I call this AB, A should be, yeah, I mean you can say A is the input is the plus side. So this is going to be plus and minus, and you can actually verify. Let's say I give you the circuit and ask you to verify if it is a negative feedback. What do you do? Break the loop. Where do I break the loop? Sorry? I mean, okay, I can break it somewhere. So let's say I break it here, and then what do you do? Let's say I increase the voltage here. I increase the gate voltage. What will happen to the source voltage? Why? Yeah. So this voltage increases. What will happen to this voltage? So we are in negative or positive feedback. That much is clear. It should not be surprising because we just replicated the block diagram. So now I'll get rid of this. So now let us check if it has become a better voltage controlled current source or not. First let's check the gain from the input voltage to the output current. So let's assume that the gain A is really large. and you know this guy is a negative feedback. So which means what can you say about this voltage here? That's approximately V in. So which means what can you say about I out? I out is V in by. So which means now you see that the gain here, the gain is basically the output current to the input voltage, that is approximately 1 by Rx. It is equal to 1 by a resistance value. So which means even though your GM of the transistor changes a lot, doesn't matter, the current to voltage ratio is constant. So which means I have made sure that the gain is kind of constant, doesn't change. So at least it has become a better VCCS in that sense. Now let's look at the output resistance. So let me erase this. So for finding output resistance, what will I do to V in? V in is 0. So this is basically grounded. So which means what I have now is the following. I have this voltage that is getting subtracted and multiplied by a gain A. So I can simplify it like this. I'll assume that this is getting multiplied with a gain of minus A. Now do you know this fellow? Have you seen this before? What is this? Gain boosted cascode. So what is my R out here? Let's say I call this M1. GM1 times, I am getting in installments, GM1 times 1 plus A times. So now if you didn't have the feedback action, so let us say this gain A was not connected in feedback, what would have been the output resistance? GM1. So GM1 times R1 times Rx. Now the addition of this feedback has basically increased your output resistance. So that's the point I wanted to make, that it is incorrect to assume that with negative feedback the output resistance always decreases and input resistance always increases. That is a complete myth. It actually depends on what kind of feedback you have, right, and what kind of a control source you are trying to mimic. Okay, so if you have a voltage control voltage source to start with and you put in feedback, it becomes a better voltage control voltage source like this. So this is that case. Similarly, if you had a voltage control current source to start with, you put in negative feedback with a large gain, it becomes a better voltage control current source. So the impedances will change depending on the nature of the control source. You can't make a generalized statement. So in a way, I'll say negative feedback is like a good college, like IIT. So you come to become a good electrical engineer, you go out as a good electrical engineer. You can't become a mechanical engineer. Similarly, you come as electrical. If you want to do mechanical engineer, you end up becoming a mechanical engineer. You can't become an electrical engineer. So same here, right? I mean, start with the VCCS, it becomes a better VCCS. So in a way, college, your college is where you not only learn Fourier transform, in 4 years you also transform. So anyways, so we saw basically 2 variants of this feedback. So similarly, you can have other variants. So we saw voltage control voltage source and voltage control current source. So similarly, you can have current controlled voltage source. So I'll not show it, I'll give it as practice problem for you to work out, it's not difficult. But here tell me what will happen to R in and R out. I am trying to make a current controlled voltage source. The input resistance should be small or large. Why? You want to make sure the entire current is sensed by your thing, so this should be small. What can you say about R out? So voltage source, you want it to be small. So this is an example where you find that with negative feedback, your input resistance will actually reduce. Similarly here, what can you say about R in and R out? We are trying to sense a current. R in should be small, R out should be large because you have a current source.